This is an overview of database objects within the Virtuoso design environment and how to access them with skill. First of all, you can use the skill language to access schematic, symbol, and mask layout design data. Two typical types of information you're going to encounter are physical information. These would be the rectangles, lines, paths, etc. that, for example, make up a layout design. They could also be the lines, solder dots, things like that that are in a schematic. Now, the other type of data that you're going to encounter is logical information. And these are things like nets and terminals, which you typically would think of as in a schematic. But in our environment, when you're using, for example, the Virtuoso Layout Editor Excel tools, they allow you to extract connectivity from the schematic and represent it in the layout also to assist you with your layout. So you will find nets and terminals both in schematics and in layouts, depending on the tools you're using. Now, when you access these database objects, what the Skill Evaluator does is it organizes the design data in virtual memory in terms of these database objects. So understanding how the database is organized will help us to understand, for example, the fact that each database object belongs to an object type. Each database object has a set of common attributes that describe that object. And the set of object types and attributes is fixed by cadence. So if you look in the documentation, you'll see a list of all the objects and their attributes. Now in this module, we're going to look at several different object types that are very common when you write skill programs. The first is a cell view object type, which is the overall cell view, like a MUX2 schematic or a NAN2 layout. Within that cell view, there are instances of other cell views. There are nets associated with the connectivity of hooking up instances. There are figures, which are basically instances and shapes and attributes related to those figures that describe that figure. And then shapes. Shapes are very predominant in the layout environment. So you might have things like paths, polygons, rectangles, etc. that would also be looked at as far as what information they contain. And then with any database object, you're also going to be able to add user-defined properties to it. And this looks like a small note here, but it's also a very important concept in the database in that, well, we have a fixed set of attributes. Any user, any company, any project can go ahead and add user-defined properties to all of these objects that are not only there during the session while the user is running the environment, but also are stored in the database for future use. Now, in order to query a design or access information about that design with skill, we'll need to use a function to get a handle to that particular database object. So with a cell view, one of the ways we can use that is to use a function called GEGetWindowCellView. And it will retrieve the database object for that particular window. So here you can see we're using the GEOpen function to open up a window with master MUX2 schematic in it. It's in fact Windows 7. Now we can call GEGetWindowCellView. Pass in Windows 7 and assign that to a variable. And that particular variable now has what we call a cell view ID in it. Basically, from there we can look at information within the cell view. You'll notice that the value returned is a DB :number. So this number represents the database object. It's good, right? If you got nil back, that would be bad in the sense that it would not have extracted a cell view ID. Maybe you gave it the wrong window, or it wasn't a design window, or something like that that would cause it to return nil. But the DB :number is important. When you see that, that means you do have a database object. Now, you would never type that DB number explicitly in there because you're essentially assigning the result to a variable. And that DB number is more of a print representation. Think of it of like, say, an internal address. So you really don't reuse that, but you use the variable MUX2 to actually then reference it for future design queries. Now there's also a similar function called GEGetEditCellView instead of WindowCellView to retrieve the database object for the design that is open in the window that you're using as an edit in place. So you can typically use these interchangeably, but if you're doing edit in place, the GE get edit cell view will get the cell view you're editing rather than the outer window from which you're editing within. So it's a subtlety, but it can be important if you're doing edit in place. But otherwise, either one works well for extracting the cell view ID from a particular window. The tilde arrow operator is an important skill function that allows you to look up information about a particular object. In this case, we have mux2 tilde arrow obj type as an example, and it returns back cell view. So the object type of mux2 is a cell view. Next, we can check the cell view type. In other words, if we know it's a cell view, we can say mux2 tilde arrow cell view type, and it tells us we have a schematic. So these are examples of queries that let us look up particular attributes about an object. So the object is a cell view. The attributes in this case are obj type and cell view type. Now, these attributes again are defined by Cadence, and you can look them up in the manual. We'll show you some other ways that you can quickly identify what type of attributes are on an object. So here's a little summary of using the tilde arrow syntax. There's a table below here. In the first column, the left side of the tilde arrow would be, for example, a database object or a list of database objects. The right side would be an attribute, question mark, and then we see the actions that we'll discuss in a little more detail here. So for the first one, where the left side is a database object and the right side is either an attribute or a user-defined property, what you're going to retrieve is either the value nil if no such attribute or property exists, or you'll actually get the value that's been stored for that particular attribute or property. Now, two other examples here are listed below where we can use either question mark or double question mark on the right hand side of the query. This is handy if you just want to know the attribute names. You can say design object like mux2 tilde arrow question mark, and you'll see back a list of all the attribute names that you can query on that cell view. Now, if you want to also see the values along with the attribute names, you can use the double question mark. So you would say mux2 tilde arrow double question mark, and all the names of the attributes and the values that are currently assigned to those attributes would be displayed in your output pane. Now, the last option here is, rather than a single database object, we would have a list of database objects on the left hand side. And then on the right hand side, we would have an attribute or a user-defined property. And what it will do then is retrieve values individually and return them in a list. So you give it a list, you say give me the attribute, and it returns a list of all the attributes for each thing in your list. Here we'll look at different examples of querying designs with the tilde arrow operator. These queries are actually from the objectives we stated in the beginning of the module. In the table here on the left hand side we have the query that we're expecting to perform, and on the right hand side we have the skill expression or expressions that will actually retrieve that information for us. So in the first query we have what is the name of design in the current window. First of all, we need to capture the cell view data object into a variable. We will then use here the GE get window cell view function. Parent indicates that we're using the current window that's active, and we capture that information into the CV variable. From there, we can query all of the information about that particular cell view. So the particular queries that we're looking at here are CV tilde arrow live name, CV tilde arrow cell name, and CV tilde arrow view name, returning the library, the cell, and the view of the cell view that's open in the current window. Next, we want to look at how many nets are in the design and what are their names. So first of all, we will have CV tilde arrow nets as our query, which returns to us a list of database objects. The length function then counts how many things are in that list. So it just says how many nets we found. Now, the next query says we want to find the names of those nets. So the first part of the query, CV tilde arrow nets, returns to us a list of all the net database objects. Now, each of those objects has an attribute on it called name. So we add to the query tilde arrow name, which gets us the entire query, CV tilde arrow nets tilde arrow name. And the effect here is that we will get back a list of all the net names. Next, we'll look at terminals. Very similar to nets, we say CV tilde arrow terminals tilde arrow name. And we get back a list of terminal names. Finally, here we'll look at shapes. How many shapes are in this particular design and what kinds of shapes are they? So the length function again takes in a list of shape objects from the query CV tilde arrow shapes and counts them. And then the type of shape is actually identified by an attribute called OBJ type. So the query here to get the object types of the different shapes would be CV tilde arrow shapes tilde arrow OBJ type. And what you get back is a list of object types, which are basically going to be strings that say this is a path, polygon, a ellipse, whatever type of object that we have in our particular list of shapes from our cell view. Within the schematic, we find instances. The example here is instance I1 of master MUX2 schematic. So the instance name is I1. We'll also be looking at the fact that it has a cell name, which is the master cell name of the particular instance that was placed here. And in this case, the cell name is NAN2. It also has some additional properties, N and P, defined on the particular instance. Here are examples of accessing the instance object and the various attributes that are stored on it. In the first example here, we want to get a list of all of the instances in the design. So the query here is MUX2 tilde arrow instances, and you'll see it returns a list, and that list is in fact a list of database objects, each database object representing one instance. Now alternatively, if you knew the name of the instance, you could use the function dbFindAnyInst by name. Pass in MUX2, which is the cell view it needs to look in, and then the name of the particular instance you're looking for, which in this case is I1 in double quotes. Then if it locates it, it will return to you the database object of that instance and store it in the variable I1. In the second example here, we'll look up the list of instance names. Here we'll use the query MUX2 tilde arrow instances tilde arrow name. So rather than just getting back a list of database objects like we did in the previous query, by adding tilde arrow name to the query, we now get a list of instance names shown in the list that's returned here. In the next example here, we want to look at a list of user-defined properties on the I1's instance. There's an attribute on instances called prop. In fact, that attribute is on all objects because properties can be placed on all objects. So I1 tilde arrow prop tilde arrow name returns a list of the property names that are stored on that particular instance. I1 tilde arrow prop tilde arrow value returns a list of the values. Now if you know the particular property name you're looking for, a nice short syntax to access that is I1 tilde arrow PW, and that will then look up the value of PW, which in this case is 11. And then the last example here, we want to look up the list of master cell names. Now the master cell is the cell from which the instance was created. So whatever library in cell view created that, for example, the NAN2 would be the master cell of the I1 instance. Here is the query then to look up all the master cell names of the instances. MUX2 tilde arrow instances tilde arrow cell name. That cell name with a capital N on name, and it will then return to you a list of all the master cell names in that particular design. The next database objects we'll look at are nets. In this example, the net SEL in master MUX2 schematic is highlighted. Here we'll see some examples of querying the net object type. We'll use the tilde arrow operator and the cell view and net attributes to retrieve, first of all, the nets in a design. We'll say MUX2 tilde arrow nets and see the list of database objects, which are nets, returned. If we know the name of a particular net, we can look it up by passing in the MUX2 cell view database object as the first input parameter to db find net by name, and then the particular net we're looking for as the second argument. So you can see here, by calling the function db find net by name, we've actually located the net SEL and the database object is returned. Next, we'll count the number of nets in a design by using the length function. So by passing in MUX2 tilde arrow nets, which is the list of database objects you see above, we now can count them and return back the value 9. Finally, we can look up the names of the nets. So MUX2 tilde arrow nets tilde arrow name returns all of the net names of the nets in our design. The next object here is instance terminals. They provide an interface between the instance and the nets in a design. Each instance can contain 0 or more instance terminals, and each net connects to 0 or more instance terminals. So in this example here, we have the B instance terminal on the I1 instance in the cell view. Here are some example queries for the instterm object. You can retrieve the following data. First of all, we'll look for the names of the instterm objects associated with the I1 instance. So in this particular case, we're going to use db find any inst by name to look up the instance I1 in the MUX2 cell view. From that database object, we're going to query the list of instterms with tilde arrow instterms, and then we're going to add the name attribute to the query to get the list of the instterm names. So here you can see it's returned the instterms named B, Y, and A. In the second example here, we'll be looking for the name of the net that attaches to the B instterm. So in this case, we're going to say db find any inst by name, look up the I1 instance on the MUX2 cell view, look up the inst terms associated with that particular instance, then look for the net that is connected to each inst term, which is an attribute on the inst term, and finally look up the attribute called name on the net. So the entire query is shown here, and you can see we get back the net names associated with each instance terminal. Next, we'll look at terminal database objects. The terminal object provides a way to connect to a net within the higher level design. Internal nets do not have terminals. In this particular case, you can see we've highlighted the SEL terminal, which in fact connects to the SEL net, which connects to the instance terminal A of the inverter and the instance terminal B of the NAND2. You'll note too that there are several internal nets in this design that do not connect to I/O terminals. And when we query those and we attempt to look for the terminal object on those internal nets, we'll get back the value nil because no terminal object exists for internal nets. Here are several examples for accessing the term database object. In the first example, we'll be looking for a list of all the terminals in the design. And then we'll look, for example, for a specific terminal. So in the first case, to get all of the terminals, we say MUX2 tilde arrow terminals and return back to us a list of database objects which are terminals. Next, we say MUX2 tilde arrow terminals tilde arrow name and get the names of those terminals. Finally, we can look up a specific terminal with the built-in skill function db find term by name, pass in the cell view mux2 and also the name of the terminal we are looking for. And if it in fact exists, it will return to us the database object. The next item we want to look for is every net connects to one terminal at most, and nil means that corresponding net does not connect to a terminal object. So what we'll do is look at the nets and then see what terminals are connected to them. So we say mux2 tilde arrow nets tilde arrow term to locate the terminals for each net. As you recall in the previous slide, we also discussed the fact that internal nets would not have a terminal associated with them. So here you can see we have several database objects returned along with several nil values. Now these nil values would most likely be the internal nets for that particular design. So since internal nets do not connect to any terminal, we can then do a query, and let's look at mux2 tilde arrow nets tilde arrow name, and you'll see in fact that net 7 and net 6 in the output here correspond to the two nil values in the query above. Here we'll look at the database objects for figures and shapes. The example we'll be looking at here is master mux2 layout, and we have instances, paths, and vias selected. One way to collect these selected items from our cell view is to use a function called gegetSELSet. What this does is to retrieve the currently selected set. So the user can interactively select objects with the mouse, and then we call gegetSELSet parent, and it returns back to us those database objects. And in this case, in the example, we're going to store that into a variable called mySet. And now we can query those objects and look at their object types with the query mySet tilde arrow obj type, and we see in fact we have a path, an instance, and a standard via. So gegetSELSet is useful when you're debugging and writing programs where you need to supply some data but not a lot of data in order to test your program. Another object we'll be looking at here are vias. Now in the 5.1 version of the tool, vias were not objects, they were cell views. In the 6.1 version of the tool, vias are objects. So here in this example, we are looking at a via placed in master mux2 layout. And by looking at the property information about that via, we can see that it is an M2_M1 via definition in the CellTech library, and it is a standard via. Here are examples of querying a via database object. We'll use the tilde arrow operator to access information about the vias. So we start out in the first example with looking up the list of vias in the design. We enter mux2 tilde arrow vias, and we get back the list of via database objects. If we want to find the names of those vias, it's a little more involved here than just adding name. We're going to be looking at the via header and then the via def name to locate the particular names of those vias. So here we'll enter mux2 tilde arrow vias tilde arrow via header tilde arrow via def name, and we'll get back the identifiers of M1 poly1, M1 M2 M1. So we'll have a variety of vias in our design that connects, for example, metal 1 and poly, metal 2 and metal 1. Next, we'll look at the technology libraries where the vias are defined. So the command here is mux2 tilde arrow vias tilde arrow via header tilde arrow via def, and from the via definition we can then add tilde arrow tech file, and the tech file object would have an attribute called lib name. So by using this query we can identify the source of the vias in our design. Next, if we want to find via locations, we can say mux2 tilde arrow vias and then say tilde arrow bbox to locate the coordinates where each via in the design has been placed. So in summary for this module, we covered database object concepts, basically how the database is constructed and things are related to each other and have attributes. Then we looked at several specific object types, including cell views, instances, shapes, nets, vias. We looked at how to use the GE get window cell view function to capture a cell view ID from a window and then use that in future queries. We also looked at how a GE get SEL set can allow us to interactively select things in our design environment and then capture those into a list of database objects to process with our skill expressions and programs. And we saw the importance of using the tilde arrow operator to get attributes and user-defined properties from database objects.